All right, so we're in book 9. We'll go ahead and talk about the book 9 test when I get back, when that's going to be. But you did the bell work. That was the first star page. Let's go ahead and talk about the answers there. All of these you could just plug in the points to see which ones you could eliminate. So looking at question 1, the correct answer was A. If you plug in all the points of that table, it only works in equation A. 2 was G. 3 was B. 4 was H. And 5 was D. So if you need some help with those, I'd be happy to help you in a tutorial session or when I get back. Now if you'll go ahead in book 9 and turn to 9.1, adding and subtracting polynomials. We did a little bit of this toward the beginning of the year when we were combining like terms, but we're going to go over it in depth today so that you feel really comfortable with it. Now the objectives that you need to know before you leave today when adding and subtracting polynomial, the first thing that I need you to know is the definition of polynomial. Okay. You're also going to need to know the definition of degree, standard form, monomial, binomial, and trinomial. You're going to need to understand how to classify polynomials. Then you'll need to be able to write polynomials in standard form and also be able to add and subtract polynomials. So you want to pause and write those down. Okay, let's go ahead and go over what the definition of polynomial is. Okay, the definition of a polynomial, which you will need to know because next time you're going to have a vocabulary test, okay, a little vocabulary quiz. A polynomial is a monomial or the sum of monomials, and we're going to call each one of those a term. Okay, we'll see what monomial is in just a moment. Okay, when we're talking about degree, we have degree of two different things. We are going to use this term in two different ways. The first way is the degree of a monomial, which is just the sum of all the exponents of the variables. Again, take notes, we'll explain in a minute. The degree of a polynomial is the greatest degree of any term. All right, when we're talking about standard form of a polynomial is going to be where the terms are in order from greatest degree to least degree. Okay, so where the highest exponent comes first, then the next highest exponent, so on and so forth. Okay, all right, so we were talking about monomial. A monomial is a number, a variable, or product of a number and a variable. Okay, we'll get some examples of that in just a minute. A binomial is going to be sum of two monomials, and a trinomial is just the sum of three monomials. Okay, notice in a monomial, it's all product, which means multiplication. You're not going to see addition or subtraction or division in a monomial. Okay, so we'll take a couple of seconds here to write what an example of a monomial might look like. Okay, you could have something like 7, right? 7's a number. That could be a monomial. You might have something that looks like 3x squared y cubed. Okay, that is a monomial. We see just a product of numbers and variables. Okay, a binomial, you might see something like x plus 7, right? X is a monomial, 7 is a monomial, x plus 7 is a binomial. Think bi for bicycle, having two wheels. This has two terms. Over here, trinomial, you might see something that says like 2x squared plus 4x minus 4. Okay, 3 monomials being added or subtracted together. All right, this next table in your notes, you do need to know in full. You will be classifying and naming things based off of this chart, okay? Kind of like a first and last name. So let's go ahead and go over those. If something has degree 0, okay, let's think about what that means. It means that its exponent is a 0. Well, anything to the 0 power just equals 1. So that's why it's going to always just be a constant or a number by itself, okay? Degree 1, we've been working with these so far all year. That is a linear function. The highest exponent of a linear function is 1. Quadratic, it's going to look like x squared. The highest exponent is a 2. Cubic, x cubed. Quartic, x4 term. Quintic is an x to the 5th, and anything that has an exponent more than a 6 is just say 6th degree or 7th degree, etc. Okay? So pause, make sure you have all of that written. The next thing that we have on here is example 1, writing the polynomial in standard form. So that means writing them in order from greatest to least. So let's go ahead and see what that looks like here. We have negative y cubed plus 3y minus 3y squared plus 2. Okay, so the degree of the first term, let's go ahead and talk about what that is. The highest exponent of this term is a 3, so its degree is 3. The highest exponent here, well, this has a 1, but we're really just concerned with what the variable is. The highest exponent on a variable in this term is 1, so it's a degree 1. Over here, the highest exponent is a 2, so this has a degree 2. And this over here is a constant, so it is a degree 0. So if we're writing this in standard form first, we've got to put it from greatest to least. So here's the greatest one. Okay, so we're going to start by writing negative y cubed. Okay, well now I've used that. We're not going to use it again. Let's go to the next highest. We have minus 3y squared. Next highest, plus 3y. Then finally, the least is 2. Voila, there is standard form. Now, it also says to identify the leading coefficient and then classify. Classify means give it its first and last name. Okay? So if we are identifying the leading coefficient is the coefficient in front of the highest degree term. Well, what number is actually in front of here? The leading coefficient is a negative 1. Naming it the highest degree is a 3, so then that would go over here to degree 3. This is a cubic. There's its first name. And there are 1, 2, 3, 4 terms. So we would have to put, since it's not a monomial, a binomial, or trinomial, we just say cubic polynomial with 4 terms. Okay, and that would be everything that you need to tell me for that. Okay. When you are adding and subtracting polynomials, it is important to note that you are just combining like terms. The exponents aren't changing. The power stays the same anytime you're adding or subtracting. So I'm going to pause and write that down. All right, let's flip over to the back of this page. All right, example 2, find the perimeter of the rectangle. Remember, perimeter just means the distance all the way around it. So the first thing that I want us to do is to identify the other lengths here. If this one's 4x plus 8, this one is also 4x plus 8. And if this one is 2x plus 3, this one is also 2x plus 3. All right, so the perimeter is going to be 4x plus 8, so this side, plus this side, plus this side, plus the final side, 2x plus 3. Now for some kids, it's really helpful to go through here and combine like terms. I recommend either circling them or giving them different symbols, or you can also color code them. So here is something with an X. Here's something with an X. Be sure to include that sign as well. Here's something with an X, and here's something with an X. Okay, oh, my 2 kind of disappeared. Okay, well, if we're talking about the perimeter here, I have 4 of them plus 2 of them. That gives me 6. Then 7, 8, 9, 10, 11, 12 X's. Okay, then let's go through and combine all of the constants. Okay, we have a plus 8 here, plus 3 here, plus 8, plus 3. Well, 3 plus 3 is 6, and 8 plus 8 is 16, so we end up with 16 plus 6, which is 22. There is our perimeter. Okay. Next example, subtract these. One thing you really need to be careful here is to identify what is actually out front here. If we're subtracting, that's the same thing as having a negative 1. So you are going to have to distribute that negative 1 through. So let's go ahead and rewrite. 2x minus 2y plus 1. Negative 1 times a 3y is minus 3y. And a negative 1 times 4x is a minus 4x. All right, now everything's rewritten. We don't have any parentheses. As soon as we kind of distribute that negative 1 and everything is clearly identified, we can take away those parentheses. So we used colors up here. Now I'm gonna say, well, what happens if you don't like colors? Well, this is an X, so I'm gonna give it a symbol, and here is another X. Again, be sure to include the operation. Here is a Y, and here is a Y. And then maybe here is a constant. You can just use different symbols to break up your like terms. So if I have 2 X's, take away 4 X's, I have negative 2 X's. If I have negative 2 Y's, take away 3 more, we have negative 5 Y's. And then we just have our lonely constant, 1. Okay, this guy here is the monster. We want to find the sum or difference. First step, distribute this negative. Distribute, distribute, distribute. Okay, so we have 3c squared minus 7. That didn't change. It's a positive, so that didn't change. But this does. And negative 1 times c squared is minus c squared. Negative 1 times 5c is minus 5c. Negative times a negative is a plus 8. Okay, so now let's combine our biggest terms first, because remember, in standard form, those come first. So 3c squared, take away a c squared is 2c squared. We have just the normal c's here. We have 4, take away 5, that's going to be take away a c. Okay, and then maybe we have just our constants here. Negative 7 plus 7, that creates a 0. So then we just have plus 8 out here. If I were going to name this guy, its first and last name. First, we need to talk about its degree. The highest exponent in this polynomial is a 2. So if you go back and look at your chart, we call this a quadratic. And this has 1, 2, 3 terms. So this is a trinomial. That would be its first and last name. Good luck. Try assignment A91 now at the very back of your packet. And if you need additional help with this, I would look at iTutoring Chapter 10, Lessons 1 through 3. Good luck. Be good for the sub.